In this lesson, we are going to talk about coterminal and related angles. Before I start with the examples, one thing you have to remember is whenever you solve a trigonometric problem, you should always remember that the answers you get are not unique. There are more than one solution, and sometimes an infinite number of solutions. So what you have to do is to find all possible solutions, and within all these solutions select the ones which are appropriate for the context of the problem. The first problem is that the sine of an angle is 3/5, and we know the angle lies in the first quadrant. We're supposed to find the exact value for cos and tan of the same angle. First of all, to refresh your memory, if we have a circle of radius r, quadrant 1 is this part of the circle. The second one is right here, the third quadrant is here, and the fourth quadrant is here. Now, if we have a point x and y on the circumference of the circle, and this angle, let's say, is theta, remember that if we draw the two lines which are perpendicular to x and y axis, this is going to be our x and this is going to be our y. So I can write that sine theta is equal to y over r, and cos theta is equal to x over r, and tan theta is opposite over adjacent, which is y over x. Knowing these facts and knowing that sine A is 3/5, I can write that sine A is equal to y over r is equal to 3/5. So from this one I can say that y has to be 3 and r has to be 5. Now, using Pythagorean theorem, in that right triangle, I can write that x squared plus y squared is 3, so 3 squared is 9, is equal to r squared, which is 25. If I move 9 to the right, it becomes negative, so x squared becomes 16, so x is plus or minus 4. Now the question is that which one of these is acceptable, 4 or negative 4? But if you look at the question, it says that it's in first quadrant. So this means that x has to be positive, so negative value, negative 4, is not accepted. So x is 4. If we know x is 4, then I know that cos A is x over r, which is equal to x is 4 and r is 5, so it's 4/5. And tan A is y over x. Y we found to be 3, so 3 over x. X is 4, so tan A is going to be equal to 3/4. The second part of the question says, determine the primary trig ratios for another angle between 0 and 360 that has the same sine value. Again, we are going to draw our circle. We found that the x value and the y value and the r value, the r was 5, the x value we found to be 4, and the y value was 3 from the previous problem. Now, we wanted to have another angle which has the same sine value, and then we have to find the cos and tan of that angle. We can see that by definition, sine is the y coordinate of the point, which is 3 in this case. Now, the only quadrant that you have y positive also is the second quadrant, which is here. Now if I find the mirror of this point on the y-axis, I get another point which is here, the same y value. So this point is going to have 3 as the y value, but the x value which is here is going to be negative of what the point had before, so it's going to be -4. So if this is angle A, this is angle B, it's going to have the same sine value, so I can write sine B is equal to the y value, which is 3 over r, which is 3 over 5. The cosine of B is going to be the x value, which is -4 over 5, and the tan B, which is y over x, which is going to be 3 over -4. Part C of the question says, draw a diagram showing the locations of the two angles and how are the two angles related. Again, I'm going to draw a circle. This is going to be my angle A. We found that angle B is going to be this angle, and the way that they are related to each other is that angle B is equal to 180 degrees minus angle A. 180 degrees is this angle, and then if you go a degree clockwise, which is going to be a negative angle, you're going to get angle B. Part D wants us to use a calculator to find the two angles. Remember that sine A was equal to 3 over 5. If you use the inverse function on your calculator, you will find that angle A is about 37 degrees. Then we found that angle B is 180 minus angle A, which is 180 minus 37, which is going to be equal to 143. There is another way we can find angle B, and that was one of the ratios that we found. We can say that cos B we found is equal to -4 over B from the previous section. If we use the inverse cos, we will find that angle B again is going to be 143 degrees. So either case, we are going to find the same angle for B. The next question asks to find another angle between 0 and 360 which has the same cosine ratio as angle A in previous example, and also the relationship between this angle and angle A. If we draw the circle again, angle A, which was 37 degrees, the coordinate of this point was 4 and 3. We know that the cosine ratio is always x over r. R is always positive, is the radius of the circle. So x here, which is 4, is also positive. We have to find another quadrant which has the x coordinate positive. The only quadrant is quadrant 4. So if I find the mirror of this point on the x-axis, I will get another point which is right beneath it, which is going to have the same x coordinate 4, but the y coordinate is going to be -3 now. Now the new angle is going to be this angle which I've drawn here. Now the relationship between this angle, let's call it B, and the previous angle, angle A, is that B now is 360, because a full circle is 360 minus angle A, which is 37 degrees, which gives us 323 degrees. The next part of the question says, now find another angle between 0 and 360 which has the same tangent ratio as angle A in example 1, and also the relationship between this angle and angle A. Again, as usual, I'm going to draw the circle. This is my angle A, which is 37 degrees. The coordinate of the point was 4 and 3. Remember, by definition, the tangent of any angle is y over x. If you look at our point, y is 3 and x is 4. Both of them are positive. Now, in quadrant 2, if you look at quadrant 2, which is here, your y value is positive, but x is negative. So another point is not going to be in this quadrant. In quadrant 3, which is here, my x is negative and my y is negative. So negative over negative is going to give me positive. So I can safely say that if I find the mirror of this point, which is going to be here, the tangent is going to be the same as the first quadrant. Now, in this quadrant, our point 4, 3 becomes negative 4 and negative 3. And the angle B, which is our new angle, is going to be this angle. Now, this angle, the relationship between this and the previous one is going to be 180 plus 37, which is going to be 217 degrees. Remember, 1/2 circle is 180 degrees. Our next example talks about two places on a grid. One represents Ted's house, which is at point -6 and 2.5. These x and y coordinates are in kilometers. So again, I'm going to draw my coordinate system. We know that the city hall is right at the origin, and Ted's house is at the grid position -6 and 2.5. Let's say -6 and 2.5 is here. I represent this one with T, which is Ted's house, so -6 and 2.5. Now, Suzette's house has the same tangent ratio. The tangent ratio, by definition, is y coordinate divided by x coordinate. So it's going to be negative here. 2.5 divided by -6 is going to be a negative number. Now we have to search the quadrant which is going to have the same sine for tan ratio. The only quadrant which has the tan ratio negative beside quadrant 2 is quadrant 4. So this means that if I find the reflection of point T about the origin, which is going to be here, this is going to be Suzette's house. Now, in this quadrant, you can see that x is positive, so this becomes 6 and -2.5 because y is negative. So you can see that Suzette is at the location 6 and -2.5. Now the second part of the question says that find the angles in standard position if the lines drawn from the city hall to each of the two houses are terminal arms. Again, if you draw the coordinate system and the two locations, which was one Ted, which we found to be -6 and 2.5, and the other one was Suzette, which was 6 and -2.5. We have to find this angle and also this angle. By definition, tan is equal to y over x, which is 2.5 divided by -6. If we call this angle for Ted's house to be theta, so tan theta is 2.5 over -6, which if you use the calculator and use the second function tan, we are going to find that theta is going to be -22.6, but since -22.6 is going to be this angle, which is going to be clockwise, but we need to find counterclockwise angle, we are going to add this one to 180. So really the angle theta is going to be 180 minus 22.6, which is going to give us 157 degrees. Now, so angle theta is 157 degrees. Now to find Suzette's house, the angle, we are going to subtract 23 degrees from 360, because the full circle is 360. We found that this angle is going to be about 22.6 or about 23 degrees. So for Suzette, the angle is 360 minus 23 degrees is going to give us something about 337 degrees. Now we are going to define coterminal angles. These are angles that they are in standard position, meaning one of their arms is on positive x-axis and they have the same terminal arm, meaning the following. Let's say you have angle A, which is 30 degrees. If I rotate this terminal angle, which is here, by 360 degrees and I go back on the same terminal angle, I get 360 plus 30, which is 390. And if I do another full rotation, meaning if I add 360 to 390, I get 750. If I add another 360 to 750, I get 1110 degrees, and so forth. This is one way of having the coterminal angles. I can also go clockwise direction, meaning I start with angle 30 degrees, something like this, and instead of turning counterclockwise, this time I turn it clockwise, meaning I add negative 360 to 30. So 30 plus negative 360 is going to give me negative 330. So this means negative 330 is also coterminal to angle 30. If I again go another clockwise direction, full clockwise, I'm going to add negative 360 to negative 330. I am going to get plus negative 360. I'm going to get negative 690. So 690 is also coterminal to angle 30 degrees. Now, the thing about the coterminal angles is that they are going to give you the same sine, cos, and tan ratios. The next example asks to find three other positive angles that they have the same terminal arm as 30 degrees. So again, if this is my circle, this is 30 degrees. If I go one full 360 degrees counterclockwise, I get 360 plus 30, which is 390. If I go another 360, I get 390 plus 360 is going to be 750. If I go another 360, 360 plus 750 is going to give me 1110. So these four angles, 30, 390, 750, and 1110, they are all coterminal angles, which is the same angles. In fact, if you use the sine on your calculator and find the sine of 30 degrees, 390 degrees, 750, or 1110, and so forth, you will see that they give you exactly the same result, which is 0.5. Now the next question says find three negative angles that have the same terminal arm as 30 degrees. Again, I start with 30, then I subtract 360 from 30 degrees. I get 30 minus 360 is going to give me negative 330. I subtract another 360 from negative 330, I get negative 690. If I subtract negative 360 from negative 690, I get negative 1050. These are all coterminals, which they have the same terminal arm as 30 degrees angle. As usual, to prove to yourself that these are going to give you the same sine ratio, find the sine of 30 degrees, negative 330 degrees, negative 690, sine of negative 1050. You will see that all of them are going to result into 0.5.